Okay, today we will continue in section 4.4. All right, we're going to continue to evaluate trig functions of any angle. These problems are presented in a lot of different ways. And then we'll also get to reference angles and the meaning of that today, okay? All right, so we left off on the next page on example 7, I believe. Yep, example 7. Okay, so this reads, find the exact values of the remaining trig functions of theta satisfying these given conditions. First thing you want to do on a problem like this is figure out where the quadrant is, where this angle lies. Okay, so I want you to write that down as the first step on a problem like this. Locate the quadrant. All right, how are we going to do that? We're going to use these skills we did on 4, 5, and 6. Okay, basically they said tangent is positive 8/15. So if we want to make an inequality so it looks just like 4, 5, and 6, you might want to do that. So tangent is positive and sine is positive. That's enough to figure out which quadrant the angle lies in. Okay, so what I recommend you do is go ahead and draw the coordinate plane. Let's just put a smart trig class right here and then think it through. Okay, so if tangent is positive, what are the possibilities for where the angle lies? It could land in the first quadrant because all are positive here. And it could lie in the third quadrant where only tangent is positive and the other two are negative. Okay, but it can't be in the second and fourth quadrant now because tangent is not positive in those two, only here. Okay, let's go on to the next condition. Sine has to be positive. Well, now we can get rid of quadrant 3 because remember, only tangent's positive, sine's negative here. All right, so it can't be quadrant 3 as well. So it must lie in quadrant 1. Okay. All right, now that we know where it lies, that's going to help us kind of draw a sketch and help us get everything else that we need. Remember, we know the definition of tangent, so we're going to use that to our advantage. Okay, so step 2, we want to make a sketch of the angle and then the triangle if you want to. You don't technically need the triangle because from day 1, I told you you could just remember that the radius is equal to the square root of the leg squared plus leg squared, which is just the Pythagorean theorem. So maybe you want an actual visual aid on that and create the triangle. Your call. I don't care. All right, so let's just say we got the answers over there. Let me cover that up one step at a time. All right, so we know it's in quadrant 1, so let's just drop the terminal side somewhere in there. We actually don't know if it's a negative angle or positive angle, but it doesn't really matter because we know the point on the terminal side. Okay, how do we know that? Because they gave us tangent. Use the definition backwards. We did some of this in section 4.3 and 4.2 as well. So since we know that y is going to be 8 and x is 15, I know the coordinate then. This coordinate on this side is going to be 15, 8. And I can go find r by either using that formula or just set up a triangle. So you can see how I drop down this side to create a right triangle. So if that coordinate is 15, 8, then I'm over 15 and I'm up 8. Okay, SOHCAHTOA works too. See how I put O over A? So the opposite side is 8 and the adjacent side is 15. So one way or the other, we can get this set up and go find the radius. Okay? Happens to be a Pythagorean triple for this one, so the radius or hypotenuse is 17. All right, now we have everything we need to go ahead and find the other trig functions. Sine is y over r. If you want to label this x, y underneath, that might be a good idea. So sine is 8 over 17. Okay, cosecant. Cosine is x over r, so 15 over 17 in secant. All right, and we could have found cotangent right out of the gate because they told us tangent was 8/15, so cotangent is 15/8. Okay. All right, so let's have you try this. Number 8, let's skip this one. I think we only need one or the other. Just a heads up though on 8, if they give you a decimal, just hit math change to fraction, and then that'll be easier for you to figure it out, right? The y over r. Here they come right out and tell you which quadrant it's in, but that's not always the case. Sometimes it's more disguised, and you got to figure that out. All right, let's take a look at 9. Okay, this one kind of tells you the quadrant as well, just in inequality form. So let's make sure we know how to read this. All right, 2 pi is 360 degrees. and this is 270 degrees. If you don't have those memorized, you can go off to the side and convert those. So if an angle is greater than 270, like 271 or 272, and less than 360, that must be in quadrant 4. Okay, if we just look at the coordinate plane, right? Because this is 270, and then 360 is to here. So it's got to lie somewhere in quadrant 4. Okay, so on to step 2. Let's use this backwards to get this going and let you kind of do the rest. Actually, I want you to try this. So since they gave you secant, you should probably just think through this as cosine is 5/7. That might be easier for you with your definitions. So given it's in quadrant 4, you pause, take a couple minutes, and see if you can find the other trig functions. You will have a radical that you should simplify. 4 goes into it. Okay, give it a shot. All right, here's your feedback on 9. So it's 2 square root of 6 is y, and this should be negative. I don't know if you remembered your signs. You got to remember you're in the coordinate plane. Positive x, negative y to get down here. The radius will always be positive. Okay, so if you put that in there, it'll take care of itself. But if you forgot to put your sign in there, go back to your rules. Only cosine's positive. Okay, everything else is going to be negative, and that's what you should see when you do this, because the secant and cosine were the only ones that were positive. Everything else is negative. Okay, let's talk about this rationalizing here. So when you have square root of 6 on the bottom, multiply it by square root of 6 over square root of 6. You don't need to do 2 square root of 6. So here's the math. Square root of 6 times square root of 6 is 6. 6 times 2, 12. And that happened again down here. Okay. Okay, let's turn the page. All right. Trig functions of the quadrantal angles. It's really just review. We've done this before. Let me remind you, back in section 4.2, we actually defined it at the top of our notes. That means an angle that's in between quadrants. And we had some mixed in here, like a negative 2 pi, for example. That was quadrantal, or pi over 2. And so they just use these coordinates, 1, 0, 0, 1, negative 1, 0. That's what we use. Okay, so we're just kind of reviewing it right here. So let me demonstrate with 10 and 12, and then let you finish it. And you should be able to come up with these coordinates on your own. And I'm pretty sure for your test, we kind of expect you to do that. Because if we have a radius of 1, you could actually choose a radius of whatever number you want, but 1's the easiest. Couldn't you come up with these coordinates on your own? Move to the right in the coordinate plane. And obviously that's 1, 0. Move up on the y-axis. Nowhere on x. 0, 1. These are things that you should be able to come up with. Okay, so when we do sine of 90, where's 90? It's rotating around to this right angle, and this is the coordinates I want to use. So using 0, 1, now we can get this. Y over r. So 1 over 1. Okay, let me show you for number 12. Secant of 3 pi over 2. Find your angle. That's 270 degrees, or think about it as pi over 2 3 times. So 1, 2, 3, right here. Okay, so here's the coordinate I need to use. 0, negative 1. Secant is r over x, so the radius is 1, and the x value is 0. So it's undefined. Okay, those go pretty quick. You try those last 4, and then I'll show you the solutions. Okay, here's the other solutions. Check your work. If not, check the definition. Okay, let's move on here to reference angles. All right, here's your definition of a reference angle. It's pretty easy once you get used to it. The reference angle is the acute angle. So remember, by acute, that means 0 to 90 degrees. And we usually denote this with theta. We call that theta prime. It's the angle formed by the terminal side, right, the ending side of the angle, and the horizontal axis, or x-axis. That's it. Okay, early on, it might seem kind of weird, like, why are we finding these reference angles? Trust me, I'll tie it in tomorrow. I'll show you how reference angles are paramount in finding all kinds of different trig functions. We will use it and tie it in tomorrow. Today, just focus on that definition, focus on the skill. So here's some visual aids on this. So for example, let me start here. Let's just say theta is 170 degrees. Well, what's the acute angle then made with the x-axis? 10 degrees. So 170, 10. That's it. Okay. Now, if it's in the first quadrant, they happen to be the same. That's kind of what they're saying right here. The reference angle is the same as theta. So if I say go draw 45 degrees, you draw it. The angle created with the x-axis is the same angle. All right, so this just kind of gives you a little visual aid. If it goes in the quadrant 3, here's your reference angle. Notice it's just the acute angle with the x-axis every single time. Don't get too caught up in all of this. Just pay attention to the definition. All right, so here we go. Let's try it. Sketch theta in standard position and label the reference angle. Okay, so the first one, 249 degrees. Let's draw it. Okay, so 249 would look like this. We always are going to start here. We're going to rotate around. So this is 180. And then we got to figure out, all right, what's left, right? 249 minus 180 gives me 69 degrees left to draw. Okay? So there we go. We continue another 69 degrees. We kind of guesstimate that around 2/3. And that angle is our reference angle, theta prime. Okay? All right, what if it's in radians? Now, I encourage you to try to keep it in radians, but I really don't care if you put it in degrees. You'll see why tomorrow when we tie it all back together. It doesn't matter if it's in degrees or radians. But taking 3/4 of something or 75% of pi is a pretty easy thing to do. So that's why I think you can handle this. All right, so here's 17. Pi is a straight angle, so I just went about 75% of that. And what do I have left? 25%, or 1/4 pi. So 3/4, 1/4. That's the reference angle. Okay, your backup plan, if things get messy, change 3 pi over 4 to degrees. It's 135. And then you can just figure out what 180 minus 135 is, what that difference is. And it was 45 degrees. So that'd be okay too. All right, so here's what I want you to do. You try 18, 19, 20, and 21. All right, try the next 4, draw the angles, and see if you can find the reference angle. And then we'll check back to check your solutions, okay? Okay, here's this one. Change into a mixed number, I think makes it pretty easy because 11/6 is 1 and 5, is 1 and 5/6. So here's 1 pi, and then I've got 5/6 pi. So 5/6, that means I have 1/6 left over. So it's pi over 6. But if you change it to degrees, then this is 330, and then you know you'd have 30 degrees left with the x-axis. So that's it. Pi over 6 at 30 degrees, okay? All right, here's the next 2, or I'm sorry, next 3. 19, even though it's a negative angle, that didn't happen yet, but when it does, just stick to the definition. Negative 220 would leave us about right here. So what's the difference from 220 down to 180? 40. You don't need to make this negative, and you might have been wondering about that. Reference angles, we usually just use positive numbers, okay? It says that in the definition probably too. Okay, this one I just changed to 2 and 1/6 because then when I do 2 pi, all I have left is that 1/6 pi left. So 5 over 6 or 30 degrees. And then here's the last one. Negative 2 and 3/4. So here's negative 2 pi. And then 3/4 of pi, 1/4 pi left over with the x-axis. So pi over 4 or 45 degrees is the answer to 21. Okay? All right, we'll tie in reference angles tomorrow into how we find and evaluate trig functions of any angle. But that's it for today.